One of the first things you've probably learned in calculus, or at least when learning about derivatives, is that the derivative of sine of x is equal to cosine of x. This is a standard derivative, and we sort of just accepted that as a fact without thinking too hard about why. So what I want to do today is unpack how we even know this is true, and prove that the derivative of sine of x is indeed cosine of x. Recall that the limit definition of the derivative for a function f of x is d by dx of f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. If we apply the limit definition of the derivative for the function sine of x, then d by dx of sine of x is equal to the limit as h approaches 0 of sine of x plus h minus sine of x, all over h. The next thing to do is to expand the expression sine of x plus h using the compound angle identity sine of a plus b equals sine a cosine b plus cosine a sine b. If we use this identity on sine of x plus h, we end up with sine x cosine h minus cosine x sine of h, and the minus sine of x stays the same, and all of this is divided by h. We can also split the fraction and rewrite this as the limit as h approaches 0 of sine x cosine h minus sine of x all over h minus cosine x sine of h over h. And what I've done is I've grouped sine x cosine h and negative sine of x into the first fraction, and the negative cosine x sine h term in the numerator goes into the second fraction. If we factor out sine of x from the first term, it becomes cosine h minus 1 over h times sine of x, and if we factor out cosine x from the second term, it becomes negative sine of h over h times cosine of x. We can use the limit law for sums to rewrite the single limit as the limit as h approaches 0 of cosine h minus 1 over h times sine of x minus the limit as h approaches 0 of sine of h over h times cosine of x, because each of the individual limits in the sum exist. We know they both exist because sine of x and cosine of x can be treated as constants since the limit is in respect to h, and sine of x and cosine of x are in terms of x, and the limits of cosine h minus 1 over h and sine of h over h as h approaches 0 both exist as well. The limit as h approaches 0 of sine of h over h is equal to 1, and this has a geometric proof, which I already did a video on, and the limit as h approaches 0 of cosine h minus 1 all over h is equal to 0, which I also did a video on. The proof also uses the result that the limit as h approaches 0 of sine of h over h equals 1. I'll link both videos in the description. So if we plug in these values, the limit as h approaches 0 of cosine h minus 1 over h times sine of x is equal to 0 times sine of x, and the limit as h approaches 0 of sine of h over h times cosine of x becomes 1 times cosine of x. The expression becomes 0 times sine of x minus 1 times cosine of x, and the first term disappears because of the 0 term, and simplifies to cosine of x. We started with the limit definition of the derivative of sine of x, and ended up with cosine of x. So the derivative of sine of x is cosine of x.